Hello, good morning. So this PowerPoint slide is presented by Group 16 and the project title is the production of gasoline from natural gas. So below are the index numbers of the students who participated in this presentation. So in this presentation, we shall look at the introduction to the main chemical product and its uses, process description and flow diagram, layout of other units on site, computer hardware needs of the plant, software needs of the plant, and lastly, we shall look at the network connectivity and topology. So without wasting much time, let's look at the introduction to the main chemical product and its uses. So the main chemical product of this project is gasoline, a refined petroleum-derived liquid fuel that is made up of light to medium hydrocarbons in the range of 5 carbon atoms to 12 carbon atoms. So in this project, gasoline is synthesized from natural gas through a route involving synthesis gas, that is syngas, methanol, and subsequent conversion into gasoline-range hydrocarbons through the methanol to gasoline process, that is the MTG process. So gasoline is one of the most critical products in modern society due to its high energy density and portability. So let's look at some of the uses of gasoline. Gasoline is used as fuel for internal combustion engines in vehicles such as cars, motorcycles, and light-duty trucks. Also, gasoline serves as an industrial solvent, a feedstock in the petrochemical industry, and a fuel in portable power generators. So the production of gasoline from natural gas presents a cleaner and more efficient fuel production option, especially in areas where natural gas is abundant but crude oil is scarce. This synthetic route provides gasoline with lower sulfur content, which is beneficial because it reduces sulfur oxide emission and contributes to improved air quality. So let's look at the process description of this project. So the process used in this plant is the methanol to gasoline process, and this is a catalytic conversion pathway that transforms natural gas into high-octane gasoline through a series of steps involving chemical synthesis and separation. It consists of the following major steps. So 1. Desulfurization. And in this process, natural gas is pre-treated to remove sulfur compounds that can poison downstream catalysts. 2. Steam reforming. Methane reacts with steam at high temperature, that's between 700 to 1000 degrees Celsius, over a nickel-based catalyst to form synthesis gas, that is carbon monoxide and hydrogen gas. So this is the chemical equation for that process. 3. Methanol synthesis. So synthesis gas or syngas is compressed and passed over a copper-based catalyst to produce methanol. That's the equation for that process as well. 4. The MTG conversion or the methanol to gasoline conversion. So in this process, methanol is first dehydrated to dimethyl ether, that's DME. That's the equation for that process. So dimethyl ether is then converted into gasoline range hydrocarbon using the ZSM5 zeolite catalyst. That's the equation. 5. Separation and analysis. The reactor output is condensed and separated into gas and liquid phases. Thus, gas samples are analyzed via microgas chromatography, that's micro GC, and liquid samples are analyzed using gas chromatography mass spectrometry, that's GC/MS. 6. Waste and safety system. So after doing all these processes, Non-condensable gases are vented, while unused liquid are sent to waste. Thus, safety system includes temperature and pressure sensors and relief valves. So let's look at the flow diagram of this process. So this is the process flow diagram of this project. So let's quickly look at some of the computer hardware needs of the plant. So let's look at the computer hardware needs of the plant. The gasoline from natural gas plant needs a comprehensive array of computer hardware to support automation, monitoring, data acquisition, and safety. So below is a breakdown of required input and output devices of the plant. So the input devices. 1. Temperature sensors. So these are placed on reactors, heat exchangers, and distillation columns to monitor thermal conditions. 2. Pressure transmitters. So these are used in reactors and pipelines to monitor system pressure and avoid overpressure. 3. Flow meters. So these are installed on gas and liquid lines to measure flow rate of natural gas, methanol, and product streams. Not gas analyzers. So this detects gas composition at various stages for process optimization. Level sensors. These monitor tank and separator level to prevent overflow or dry runs. Face recognition or ID scanners. These are installed at access points to enhance plant security. And lastly, barcode scanners. So these are used in inventory management and equipment tracking. So let's look at some of the output devices. We have alarm systems. So these provide audible or visual warnings for process deviation or safety breaches. 2. HMI screens, that is human machine interface. So this display process graphics for operator interaction. And we have data loggers or servers. So these store and archive historical plant performance data. So let's look at the software needs of the plant as well. So for the efficient operation of the plant, it does not depend only on hardware but also on some powerful software solutions. So the following are software categories that are needed by the plant. So we have process control software. So these are for real-time monitoring, control, and automation of the plant processes. 2. Data acquisition and SCADA systems. So these are used to visualize plant parameters and trends. We also have simulation and modeling tools such as Aspen HYSYS, and Aspen Plus. So these are used by engineers to simulate reaction and separation units for design and troubleshooting. And we have Enterprise Resources Plan, and that's ERP. And these are used for managing inventory, procurement, human resources, and financial operation. We also have cybersecurity software. These are used to protect operational technology system from external and internal threats. So, so let's quickly look at the network connectivity and topology of the plant. So to support the real-time data exchange, automation, and monitoring, the plant should deploy a robust and secure network infrastructure. So let's look at the network connectivity type. So a hybrid wired, that's Ethernet and wireless network, is ideal. That is, wired connection should be used for critical systems, while wireless access can be used in non-critical zones. So let's look at the network type. 1. LAN, or the local area network. This is used for communication within the plant. 2. CAN, or the controller area network. This is used for efficient real-time communication between sensors, controllers, and actuators. 3. VPN, and the VPN is used for remote monitoring and secure access by authorized personnel. So let's look at the network topology of the plant as well. So 1. A style topology. A style topology is recommended for the plant's IT network, where all nodes are connected to the central switch. So this improves reliability, allow allows easy troubleshooting, and enables fast communication. 2. A bus topology, and this is a type of network setup in which all devices are connected to a single central line called the backbone. So finally, let's look at the layout of other units on site. Let's quickly look at the layout of other units on site. So apart from the core process unit, the production site will also include several auxiliary facilities that support plant operation and ensure safe and efficient production. So below are some of the facilities needed on site. 1. Control room. So the control room houses the distributed control system where process parameters are monitored and controlled. Also, operators can observe real-time data and respond to alarm. 2. Utilities area. So the utilities area contains boilers, cooling towers, and compressors that supply process steam, cooling water, and air. 4. 3. Laboratory. So the laboratory is used for product quality analysis and catalyst testing. And the last one is storage and loading base. So over here, tanks for storing methanol, gasoline, and feed gases, along 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 with along with loading and unloading areas for trucks and pipelines are also kept here. This is the end of our presentation. Thank you.